Okay, guys, so what I'm going to do is I'm going to go through, somehow I missed 8.2 video. So I'm going to go through and do this as if it were our first time in class, and I'm going to solve this. So this is our warm-up, and so to be able to get a common denominator, or to be able to combine these, I need a common denominator. So this is what you would do, and that gives me 2 minus the root of 3 all over 2 all over 2. Okay? This is your top half. This is your top half right here. Now, to simplify this even more, I put this over 1, and I'm going to multiply it by 1 over 2, and that gets rid of this. Now, I've made my pen very small. I needed it smaller, so I'm just going to increase that. All right, so now this is going to be the square root of 2 minus the square root of 3 all over 4, and that lets you split, because you have a fraction, 2 minus the root of 3 all over the root of 4, and guys, the root of 4 just comes out as a 2. So that means final answer, square root 2 minus root 3 all over 2, and we're done. To factor this one, I'm going to subtract 3 from both sides. We spend a day of factoring. So this is 4x squared minus 5x plus 1 equals 0. You make a diamond by doing AC over B divided by your AX. In this case, 4x. Okay, and your A and C are here, so that gives you 4 over, that was a 4, over negative 5. And then what two numbers will multiply to give you the top? Well, 4 times 1, and add to give you the bottom. Oops, it's a negative, so we have to make both of those negative. Reduce these where you can. This side doesn't reduce, so it leaves you two factors, x minus 1 times 4x minus 1 equal 0. To solve it, you get x equals 1 because you set both pieces equal to 0, and it splits it. And then this side is 4x equals 1 divided by 4x equals 1/4. These are your two answers. Okay, moving on down the page. Previously, we learned that sometimes we need to factor trinomials and to solve equations. However, we can do this only if the function is written in terms of one trig function, and it is set equal to 0. If a function is a squared term, then one trig function and the non-squared term of the different is a different trig function. We need to use identities to get all of them to be the same trig function. You cannot factor with a sine and a cosine, one of them being squared and one not. Okay, you have to change them. We'll get some examples. So here, notice I have a sine, so everything has to be left in terms of a sine. So that means this one has to switch. And if you can remember, we have sine squared plus cosine squared equals 1. So if you want cosine by itself, then we subtract sine squared to both sides. So this is 1 minus sine squared theta. Now I can collect like terms. This is a like term with this one. So 1 minus 2 sine squared theta. And I didn't mean to do that. I clicked my pen. Sorry. Oh, shoot. Stop it. Oh, my gosh. I'm going to lose my mind. Why did this do this? It's like drawing everywhere. Eraser. Eraser. Erase. Erase. I don't know why this went nuts. My apologies. Draw. And let's see. It's not doing that anymore. Good. Theta plus sine theta equals 0. Okay, so what we have is a sine squared term, a sine term. So I'm going to rearrange this. -2 sine squared theta plus sine theta plus 1 equals 0. Well, I'm going to set up my diamond, and I'm going to work this the way the kids asked me to in class. I don't know that I agree with this that it's the best way. Now, what we did on factoring with these, we let n equal sine theta. So what we have is -2n plus 1. So that means this would be -2 on the top, 1 on the bottom from one end, and the two side numbers would be -2n, -2n. Okay, that is a negative. It's hard to see it right there. So what's going to go into this is 2 and a 1. And one of these have to be negative. We want the bottom number to be positive, so the second one is negative. And what reduces is this one right here. But be careful, there's a negative right there. So I'm going to move the negative up, and this reduces to a -1. This has a double negative, so I'm going to cancel the double negative. And what it leaves me is this. Whoops, there was supposed to be a squared on that. All right, I think I said it, didn't write it. So this is going to be an n minus 1 times 2n plus 1. Okay? Now what happened in this, notice that if you check these, this times this is a positive 2n squared, not a negative 2n squared. And the two back pieces, this times this, is a -1, not a positive 1. Because of this negative being in the denominator, it factored out a -1. But if it's set equal to 0, it would cancel anyway. You divide by -1, and it's gone, and this is still 0. Okay? So know that that's what happens. So what this comes down to, we're going to let that n equal sine theta again, and what we're going to have is sine theta minus 1 times 2 sine theta plus 1 equals 0. So this is where you split it and let both pieces go to 0. Sine theta minus 1 is 0, so sine theta is 1. And this is going to be 2 sine theta equals 0. I already see that there. I'm not going to rewrite it. So 2 sine theta equals -1, divide by 2, and I get -1/2. So I have sine theta and sine theta. Well, your final answer comes from going, well, what can theta be? And this comes from your unit circle. So if you have your unit circle handy, where is sine theta 1? Well, it has to be at one of the axes. So this is 0, out 0, up 1? No, it's out 1, up 0. I almost did it backwards. 0, 1, -1, 0, and 0, -1. That would be where all these places are, right, on the unit circle. So where this is cosine sine. Oh, so the only place it happens is up here at pi over 2. So this answer gives you pi over 2. What about this one right here? Sine is -1/2. First of all, for it to be sine negative, it has to be in this quadrant and this quadrant, either one. So sine is 1/2 at pi over 6. So these are the two pi over 6 areas. This is going to be 7 pi over 6 and 11 pi over 6. And there's my 3 answers. All right, doing the next one. Okay, cotangent, cosecant. I want to say I took this one out. You have to get this in terms of cosecant. I can do this one, and that's using cotangent squared plus 1 equals cosecant squared, and these have x's on them, of course. So if I want to replace that, I'm going to get cosecant, and that's not cosecant. I thought I was going to get through a problem without doing that with cosecant. Cosecant squared x minus 1 minus cosecant, I did it again, cosecant x. Let's pull this minus 5 minus 1 equals 0. Okay, I just wanted to combine that as I went to save a step. I'm still not done because I still have like terms that are not combined. So cosecant squared x minus cosecant x minus 2 is 0. Now I'm ready to do a diamond. I'm going to do the same thing. I have n squared minus n minus 2. N squared minus n minus 2. Nope, not the one that I had over there. I was looking to see if I could still those factors, and I cannot. So negative 2, negative 1 leaves me with n and n. And what goes over n? 2 and 1. And I have to subtract the 2 and add the 1 to get the negative 1. So this is going to give me n minus 2 times n plus 1. So going then from this one, it's going to give me cosecant, x minus 2 times, and this is where I'm going to split it, times n plus 1, cosecant x plus 1 equals 0. So I'm going to set both of these equal to 0. Okay, so cosecant x equals 2, cosecant x equals negative 1. So what you do with cosecant, and the rule for this, is that it becomes 1 over sine x. And 1 over sine x equals negative 1 over 1. These two things just flip. That's the rule for it. So sine of x is 1/2, and sine of x is negative 1. It just so happens for this one, it doesn't matter which way it goes. So x is equal to, well, where is sine of x 1/2? Sine of x is 1/2 at the pi over 6 mark. So it happens, it's helpful to have this. You get this at pi over 6 and over here. So pi over 6 and 5 pi over 6. I had to think a minute. 5 pi over 6. And it's negative 1, which means out 0, down 1. Out 0, down 1. It's that second one that has to be. So this is at 3 pi over 2. Okay, there you go. Done with this one. All right, looking at this one. This one, I have sine squared and I have a cosine. Cosine is not squared, so I have to change these into cosine. So remember, sine squared plus cosine squared equals 1. We need x's or thetas with them. And that means if I want to solve for sine, I'm at 1. Be careful, I have 2 times 1 minus. This is the only piece that can change out. 1 minus cosine squared theta. Okay, so that gives me 2 minus 2 cosine squared theta, because I got to distribute the 2, minus cosine theta minus 1 equals 0. Now, the 2 and the minus 1 are on the same side of the equal, so I have negative 2 cosine squared theta minus cosine theta plus 1 equals 0. I combine my like terms of 2 and negative 1 to give me this 1. I'm going to go ahead. This one, I want to factor out a negative and show you what happens. If I pull out a negative 1, it leaves me 2 cosine squared theta plus cosine theta minus 1 equals 0. Now, if I divide by -1, this is gone, and this just maintains its zeroness, okay? So this becomes 2n plus n minus 1, and that negative's factored out to begin with. I don't like the negative being on the bottom because it doesn't make sense. So once I have this, I have -2 over 1, so I have 2 and 1, and of course I have a 2n and a 2n. This one reduces to 1, this one doesn't reduce, so this factors out to n plus 1, 2n. Now wait a minute, I should have had a negative somewhere. It's 2 minus 1. 2n minus 1. There we go, equals 0. So if I plug in cosine back to that equation, I'm at cosine of theta plus 1 times 2 cosine theta minus 1 equals 0. Let's split it. I get cosine theta equals -1, and cosine theta equals, pulling the 1 over makes it positive, dividing by 2 makes it a half. So what is theta equal to? Well, on this side where it's -1, it helps to have unit circle. That means that I have -1 to start with. This is -1, 0, so this is at pi, and that's the only place it's true. Cosine being a half means it's in the first position, and that's up here at pi over 3. And then cosine is also positive down here at 5 pi over 3. So that means this is pi over 3 and 5 pi over 3. And we're done. Next. All right. So you can square both sides. I don't like squaring both sides because when I square both sides, I get cosine squared theta equals sine squared theta, and they don't match. I can't add or subtract them, so I have to change one of them. So I'm going to change this one to 1 minus sine squared theta. I will say squaring both sides is rather unusual. You can do it. It's just not my favorite way. All right, they don't always come out real nice. Plus sine squared to both sides. And there's more than one way to do this, as most math. 2 sine squared theta. I'm going to divide both sides by 2. And then I'm going to take the square root of both sides. So that means I have sine theta equals plus or minus. This thing is the square root of 1 over the square root of 2, which gives me 1 over the square root of 2, rationalized as square root of 2 over 2. Okay, so where does that happen, plus or minus? Guys, there are 4 places this happens. It's here, 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 at all the pi over 4s. Okay, so theta equals pi over 4, and 4 would be 3 pi over 4, and 5 pi over 4, and 7 pi over 4. Okay, that's all the pi over 4s. Now, what we have to be careful of, I'm going to label all of these, is that when we square it, we may be adding numbers in there, adding solutions in there. There's no maybe, we are adding solutions, because that means now we can have, when something is squared, we can have 2 solutions as opposed to 1 solution. So we're going to have extra solutions in here. Now, the original problem said cosine theta is sine theta before we decided to square it. That was not the original problem. Where are sine and cosine equal to each other? Right here and right here. Why are they not equal to each other here? Because one is positive square root of 2 over 2, and one is negative square root of 2 over 2. They are not equal here, which means this answer and this answer cannot be used. So whenever you decide to square both sides like this, you can do it, but you're adding an answer and you have to go back and double check for extraneous solutions, okay? These are just rules that you can pause and look over them. Reminders of what to do. Now, this answer, you can just steal the answers from the last one. This ended up being all the pi over 4s. So I am not going to go back and do that just to save a little time. It's the pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, just saying. All right, this one I'm actually going to skip it because it's secant cosecant. So we're going to skip through that and go on. All right, so this one I definitely want to do. This is very different. These two do not match and they have to match. So we have to take this, use the rule on the pink sheet or on the back of your blue sheet. It's 2 sine theta cosine theta. And then this repeats, 2 sine theta. This made no difference. It didn't change, excuse me. And so now you have to look at it and say, well, what can I do to this? Notice there is a 2 sine theta here and a 2 sine theta there. Please be careful here. That's 2 sine theta times. Well, what times 2 sine theta is going to give you 2 sine theta? Not 0, 1. Kids leave it out all the time. Minus, well, the only thing left over here is cosine theta. So that gives you 2 sine theta equals 0 and 1 minus cosine theta equals 0. So sine theta, trying to say it, is 0 and cosine theta equals 1. If I pull this to the other side, it would make it positive. So I can just rewrite it the other way. So what are my answers for theta? Okay, where it's 0, let's see. This is out 1, up 0. That's sine. Ooh, that means this negative 1, 0 would also work. So that gives me a 0, pi, and a 2 pi. Well, where cosine is 1 is where, oh, this is cosine. This one gives me a 0 and a 2 pi, but it's already listed, so it's done. These are my only answers. I think this may be almost my last one. Okay, this one, we have to go back and look on our pink sheet. What is the possibility for this? So this is cosine squared minus, and guys, I am not making these up. These are the rules, okay? These are your identities. I wouldn't make up stuff like this. I'm not that good. Okay, so this becomes, remember, sine squared plus cosine squared equals 1, right? So this is solving for cosine is good. 1 minus sine squared theta minus sine squared theta equals 1. And if I decide to subtract 1 from both sides, that's going to give me negative sine squared theta minus sine. Well, why did I keep 2 of them? I'm crazy. Let's get rid of this, and I can just collect my like terms. Negative sine plus negative sine is going to be negative 2 sine equals 0. Yeah, I'm just double checking all of my work. Did I do absolutely the right thing? Subtracted 1? Yes, there's nothing wrong with this. Divide by negative 2, I get sine theta, sine squared theta equals 0. Dividing by negative 2, not minus 2, dividing by negative 2, I end up with 0. Taking the square root, interestingly enough, I get sine theta equals plus or minus 0, but as we know, that's not necessary. So where is sine 0? Well, that's out 1, up 0, right there. It also happens over here, right here. So that's going to be theta is 0, pi, and 2 pi. Okay? This one I want to do because this one you could be responsible for. 1 plus tangent squared x equals secant squared x. So I can replace this with that. And that's exactly what I want to do. 1 plus tangent squared x equals 2 tangent x. This needs to move to this side, and I'm going to rearrange it as I go. I'm going to put this up front, tangent squared x minus 2 tangent x plus 1 equals 0. I just moved the plus 1 all the way down to the end. Okay? So that gives me, this is like an n minus 2n squared minus 2n plus 1. So this gives me 1 on the top, negative 2 on the bottom, negative 1 all over n over n. And if you figured this out, that means it means tangent minus 1 times tangent minus 1 equals 0. Do I have to do this twice? And the answer is no. I only have to show that one of them are 0 because I'll get the same answer twice. And I'm leaving out my x's, sorry. So tan x equals 1. Where is the tangent 1? And I don't get a plus or minus. It happens at pi over 4 because we end up with the square root of 2 over square root of 2 over 2 over square root of 2 over 2. Tangent equals 1. And it also happens right here at 5 pi over 4. So our two answers are x equals pi over 4 and 5 pi over 4. Okay? And that may be it. No, I need to do this one. This one we've got to take enough room, and this is taking some time, and I'm sorry for that, but too many kids are doing this the wrong way. First thing I want to do, I'm going to make it a bright color. It does not go to this. It is not sine theta plus sine pi over 4. This is a big no, no, no. All right, this is how you have to do this. Go to the blue sheet or a pink sheet, and you're going to go, this is like your A and your B, your A and your B, and we have sine of A plus B. So this one, and I'll color code these so you can see it happen. You get sine of theta times cosine of pi over 4 plus, that's a plus sign, and for sine it's a plus, so cosine theta times sine pi over 4. Changing to green, plus for all of this, sine theta cosine pi over 4 minus cosine theta times sine pi over 4 equals 1. Now here's the thing, guys. We need to see what's happening at pi over 4. Well, that's square root of 2 over 2 and square root of 2 over 2. All right, so if that's what we have, every last one of these cosine sine pi over 4 goes to square root of 2 over 2. So this is gone, and what we have is square root 2 over 2. This is gone, square root 2 over 2. Root 2 over 2, root 2 over 2. So what that means we have underneath here is the square root of 2 over 2 is just a number. It's irrational, but it's just a number. So it's that times the sine of theta. I don't like it behind it because we don't say sine theta times 2. We say 2 sine theta, right? So plus square root 2 over 2 cosine theta plus square root 2 over 2, square root 2 over 2 sine theta minus square root 2 over 2 cosine theta. All right, with that said, it just got a little bit shorter. Now we've got to look, what else do you notice that happens here? And at the class, somebody caught it when we were doing it. These two are opposites, so they're gone. And now I have how many of these square root 2 over 2 sine thetas do I have? I have one here. I have one here, giving me 2 square root 2 over 2 sine thetas equal to 1. Now, doesn't that look a lot shorter? Should. All right, now what's cool on this is that when I have 2 times something, that's the same as 2 over 1, and this goes away. And so I'm left with the square root of 2 sine theta equals 1, and then I'm going to divide both sides by root 2 over root 2, giving me sine theta. I've got to rationalize this piece up here, square root of 2 over 2. Okay, so that means theta is equal to, oh, would you look at this? We already have it drawn. That's going to be at pi over 4. So this happens, where's the 2 places it's positive? Here and here. So this happens at pi over 4, and it happens at 3 pi over 4. And I'm done. Guys, I believe that is it. And I am out.